This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today I'm delighted to have two guests from the University of Georgia. Sybilla Beckmann is the Josiah Meigs Distinguished Teaching Professor in the Department of Mathematics at UGA. So Sybilla, thanks for being with us.
Thanks so much, Sam. Great to be here.
And Andrew Izsák is a professor in the Department of Mathematics and Science Education at UGA. Andrew, thanks for being here too.
Thank you, Sam.
We're going to be talking about their new article in the Journal for Research in Mathematics Education, Volume 46. It's in the current issue, and it's entitled, Two Perspectives on Proportional Relationships, Extending Complementary Origins of Multiplication in Terms of Quantities. So this article is really interesting. It unpacks some important mathematical ideas with regard to proportions, and it presents these new perspectives that I think most people probably haven't really thought of it in this way before. But before we got to the proportions, I wanted to back up, and I was wondering if you could just talk to us about multiplication and division and maybe some of the different perspectives that there are on those two operations as a way to kind of build us into your work that you did on proportional relationships.
We think that the heart of this article is, if you just wanted to reduce it into a sort of one sentence, the heart of this article is about systematically tracing out the consequences of distinguishing the multiplier, which describes the number of groups, and the multiplicand, which describes the size of the groups, as a unifying way of thinking about multiplication and division situations with whole numbers, multiplication division situations with fractions, and proportional relationships. That analysis, separating the role of the two factors into multiplier and multiplicand, has been carried out in previous well-known math ed work on division, makes a distinction between measurement or quotative division on the one hand and partitive or sharing division on the other hand. And what's new about this article is that it extends this kind of distinction systematically to thinking about two different ways to interpret ratios and proportional relationships between quantities.
So, for example, if we think about m times n equals p, a multiplication equation, then really, if you think of multiplication and division situations, those are basically ones where two of those three, m, n, and p, are known, and the third is to be determined. And so that's how we get multiplication and then the two types of division situations, or two types of quantitative views of what division can mean. And now what we have done is to extend that idea to cases where there are two unknowns. And so that single equation, m times n equals p, actually unifies not just multiplication and two division situations, but also inversely proportional and then two distinct types of proportional relationships. And so if you want a simple example of the two types of proportional relationships, I'm not going to get into complete details in terms of how that works with m, n, and p, but just the multiple batches, which is the more familiar one in math education research, is basically where you might have 2 cups of grape juice and 3 cups of peach juice, and you kind of think of that as making a batch, one batch of a punch mixture. And we can make copies of that batch, and as you make multiple copies or maybe fractions of a copy of that batch, you get different amounts of punch, but they're all in that same 2-to-3 ratio. So that's one way of thinking about what it means to be in that fixed 2-to-3 ratio. But then a different way, this variable parts perspective, which is not so familiar and has really not been researched in math education, is where we think of maybe having 2 containers and 3 containers, and the 2 containers we're going to put grape juice in, and the 3 containers we're going to put peach juice in, and we'll keep the level the same in all of those containers. But we can vary the volume of juice in the containers simultaneously, and that would give us the variable parts perspective on what it means to be in a 2-to-3 ratio. Different amounts of grape and peach juice, but they're all in that fixed ratio. But it's a different way of thinking about how those amounts are organized, or how we're thinking about those amounts, than in the multiple batches.
Because in the first way you described it, you're kind of using, to me, like equivalent fractions. Like you could have 2 to 3, but you could also have 4 to 6, and you can and that's kind of the same way of thinking about just having more cups of it and more cups of it. But then the second way you're describing it, it's really just keeping that 2, 3 front and center, and it's not going to equivalent fractions or equivalent ratios. It's actually just changing the size of that same 2 to 3 ratio. Am I getting that correctly?
Well, you'll still get equivalent fractions out of that, or equivalent ratios, because if you think about how much you put in each container, if I put 2 cups in each of those containers I was describing, then you'll get 4 cups of grape juice and 6 cups of peach juice. You're still getting the 4 to 6 out of that. But you're right in some sense that you can almost let those units fade away, and those individual amounts, kind of the numerical values of those amounts, you could almost let fade away in some sense.
Right, yeah, that's kind of how I was thinking. Like the equivalence is still there, but in terms of the kind of the whole numbers that are really sticking out visually or conceptually, to me, in the first example, you actually have different whole numbers, but they all form an equivalent fraction or an equivalent ratio. 2, 3, then 4, 6, and then something else. But in the variable parts situation, you maintain the equivalence, but the whole numbers that are staring you in the face, they actually just stay 2 and 3, 2 to 3.
Mm-hmm, mm-hmm.
So I'm curious, too, about where, like you said, this variable parts and this way of distinguishing between perspectives on proportions is new as far as I know in the literature. So I was wondering where this article originated from. Usually when I'm interviewing people here, they're doing a research study, they're collecting data, and then they do some analysis, and so it's pretty clear where the article came from. But I'm curious where this article started from.
Yeah, this is really different because it's purely theoretical, this article, and its origin really is back almost maybe 10 years ago or so. When I was writing one of the early editions of my book, I felt like I needed a careful mathematical definition of what it means to be in a given fixed ratio, like a 2 to 3 ratio. And when I started formulating that, I realized there had to be 2 distinct ways of defining what that means that basically parallel the 2 distinct quantitative definitions for division, the measurement and the partitive, or the how many groups and how many in each group. And I realized that I hadn't noticed that in the literature. Not that I was extremely well versed in it, but I had read some, and I hadn't noticed that distinction being made in the literature that I had read. And so I went around and was telling various people about it, but people would kind of say, oh yeah, or not really, engage with it. And I thought that was kind of surprising, so I kept at it, kept asking people to consider those perspectives. And really, it took a long time, obviously, to kind of get these 2 perspectives to be written about in a more careful, or from a math ed perspective. So they have been in my book for quite a number of years, but it just hasn't been picked up in research. So I'm incredibly grateful to Andrew for working with me, and we pushed it way beyond what was in my book. This unifying idea that we were just talking about, that's something we worked out together in the last few years.
And another way that the paper pushes the idea forward is it brings in the notion of cognition. And so I was wondering if you could say a little bit about how psychological research and ideas of cognition fit in with this kind of mathematical way of thinking about perspectives on proportion.
Right, so in our conversations about the 2 perspectives and in considering how to craft an article that would be appealing to JRME readership, we understood that in addition to having a mathematical analysis which mapped out sort of the terrain of possibilities, it would also be very helpful to have an argument that the range of things that were possible from a math analysis would also be sort of psychologically accessible to learners. And so this part of the paper tries to make the case that in various places in past research on multiplicative reasoning, you do see sort of little hints of the kind of distinctions that we really focus on in the paper. So, the details are in the paper, but we point to passages from Jim Caput's work on ratio and proportion from the 90s. We point to work on the operator construct from the Rational Number Project. We point to Jared Comfrey's work on splitting and to Les Steffie's work on units coordination as a sort of a range of places in past work where you sort of see little kernels that particularly the sort of notion of variable parts might be accessible. At least other sort of main thinkers in the multiplicative reasoning work, have considered this idea of changing the sizes of the parts as a reasonable idea for students. I do think at the same time it's an open question about, for future research about exactly how accessible the variable parts point of view is. We know that the batches point of view is accessible to students, and we know from past research that it's significant because presented with covariation situations, young students might focus on just one quantity changing or just the other quantity changing, and actually being able to coordinate the changes in two quantities together is a significant accomplishment, and one of the ways that empirical work has documented children are able to do that is through this batches perspective. They form a 3-to-2 batch and then they start making copies of that, and that's a significant milestone because it is the first time where the sort of coordination of two quantities changing together is accomplished successfully. And it'd be interesting to know sort of what the similar avenues might be with the parts perspective.
Yeah, and I think you mentioned earlier fractions and having fractions be involved in that mn equals p equation. This leads me to a lot of questions about how the student's thinking might, work with fractions. So if you're doing the batches, it seems easier to do a kind of another complete batch, but you could do, another portion of a batch. But then with the variable parts, it seems like you could kind of scale to any real number. You could kind of say, okay, we have the size of these 2 cans over here and the size of these 3 cans over here, and I can imagine scaling them continuously to any fraction or any decimal, things like that. So I was wondering if you have initial thoughts on those, or at least hypotheses about students thinking with these different perspectives.
We have a slightly different conjecture, which is that this idea of batches, in light of the body of work which already exists on children's thinking about proportional relationships, the batches perspective may be a very useful avenue into this sort of initial successful coordination of two covariant quantities. But the batches perspective may not always be sort of the best foundation for thinking about applications of proportions to subsequent topics. So it could be that batches provide an avenue into sort of fixed ratios, but that the parts perspective doesn't replace the batches perspective, but provides a sort of a significant complementary perspective that is particularly useful for applications, particularly ones that have any kind of sense of similarity to them, in geometric similarity. So that would include topics like slope, and we even think maybe thinking about relationships between samples and populations.
Yeah, so Sam, where you were just mentioning, you could imagine the number of parts staying fixed and the size of them varying. You can picture lots of similarity situations in exactly that way, and also even lines and slope can be connected to that kind of idea, and so we think that might be a new route into some of these difficult topics.
Now earlier Andrew mentioned quite a few other bodies of literature that you connect to in your article, and I'll refer the listener to the article for those details. One that I did want to get you to comment on, though, if you could, is the idea of within measure spaces and between measure spaces, and that idea comes up in the article a few different places. So I was wondering if you could just comment on how you see your perspectives on proportions coming into dialogue with the ideas of measure spaces.
Yeah, and Andrew mentioned earlier that people have researched, different ways that students may reason about proportional relationships. They may use various different strategies to get different amounts that are in the same ratio. They may use something like a building up strategy or other kinds of strategies. And one thing that we did was to make a distinction between this within measure space versus between measure space distinction and our two perspectives, the two perspectives on proportional relationships. So we actually argue in the paper that those are orthogonal distinctions, that they are very separate and very distinct. And we do that by showing that for each of the two perspectives, you can reason within measure spaces and you can reason between measure spaces. Some of that has been explored in the literature on children's reasoning, and children have been found to reason in various different ways from the multiple batches perspective. But we think also that some other ways of reasoning will be accessible to learners from the variable parts perspective. Hopefully there'll be different avenues and into some of these topics that are known to be difficult. But the other thing that I wanted to add to that was, remember earlier I was talking about how I wondered for so long why people were not accepting and were not enthusiastic about these two distinct perspectives on what it means to be in a given ratio. Because to me, it's always seemed really neat. I mean, it seems really cool that there's, for one, it seems cool that there's these two types of division. That's cool in and of itself. And then on top of it, that there's two types of proportional relationships. That just seems even cooler. So why was everybody, just kind of dismissing it or not really recognizing that it was as cool as I thought it was? And I think one possibility, and of course we don't know, but we've speculated that perhaps it was exactly this within measure space versus between measure space distinction versus the two perspectives, that people were actually conflating those two. So that was what we were trying to talk about quite carefully in the article, that those are not the same thing. They're distinct. And so hopefully this will help people see that there's this other distinct perspective.
My guests are Sybilla Beckmann and Andrew Izsák from the University of Georgia. We're talking about their article on proportional relationships in JRME. So I was wondering if you could comment on some of the broad implications that you see for the future stemming from this article, because this does lay a theoretical foundation and it articulates this idea on the perspectives of proportions, and it distinguishes it from measure spaces and other things like we were just talking about. So what do you see going forward from this piece?
In addition to the framework that we lay out in the JRME article, we have also, for the last couple of years, been conducting empirical investigations with pre-service teachers, examining their capacity to reason with the two quantitative perspectives on ratio and proportion. Last year, we conducted pilot work that was supported by the Spencer Foundation, and we were able to use results from that pilot work to write a successful NSF proposal that's been funded by the REAL program. And in that new project, we are investigating pre-service teachers' understanding of multiplicative reasoning among quantities. And sort of the three research questions have to do with understanding kind of the ecology of multiplicative reasoning with quantities, multiplicative relationships with whole numbers, fraction multiplication, division, understanding how that serves as a foundation for reasoning or developing a capacity to reason about ratios and proportions quantitatively from the two perspectives, and finally examining how pre-service teachers might be able to apply those two perspectives to situations that sort of fall under this broad umbrella of geometric similarity, so including topics like slope and relationships between samples and populations. One feature of the project that connects to our previous conversation on these math ed podcasts is that we are using the profiles, the attribute profiles that we talked about last time, as a mechanism for selecting pre-service teachers for a series of interviews and in-depth data collection. So it's a collaboration that includes Lainey Bradshaw as well.
We do hope ultimately that people will pick up on these two perspectives also for work with children, not just with pre-service teachers. So we're working with pre-service teachers, but it's something we think can be used across all the grade levels. And we do know that these topics, ratio and proportional relationships, are really central and really foundational for a lot of math and a lot of science. So it is worthwhile to investigate what the affordances might be of a different way of thinking about these ideas.
Mm-hmm. Well, thank you very much for bringing them to our attention. The article, again, is in the current issue of JRME in Volume 46. Before I let you go, I have one more just kind of fun question to ask. If people are interested in Andrew's alternative career, they can go back to episode 1402 when he was a guest earlier. Right now, we're recording this in January of 2015, so I can still get away with some kind of New Year's type questions. So I'll ask both of you, what are you most excited for in 2015?
Well, I'm actually most excited for our research project. I think it's really fun, and I'm new to the study of cognition, and so I'm having really a wonderful time working with Andrew and learning about how to study cognition. And to me, it's just really exciting and really fun, and I just pinch myself all the time that I'm getting to do this great work and have so much fun at it.
Yeah, we have a very nice collaboration, and I'm very interested to see results out of the project, this NSF project. It's based, the primary data are interviews with teachers selected from content courses that we teach. We're just in our first round of data collection. It's sort of too soon to have preliminary results, but we're very, very interested to sort of try to trace sort of all the subtle nuances in the ways that pre-service teachers reason about this critical content, and maybe having insights about not just the two perspectives per se, but sort of more fundamentally about multiplicative reasoning.
Well, Sybilla and Andrew, thank you so much for taking the time to speak with us. We appreciate your work.
Thank you.
Thank you.
Thank you for listening to this episode of the MathEd Podcast. If you'd like to support the podcast financially, please use the PayPal donation button at mathedpodcast.com.